Let's take one more example. Y of s divided by u of s is equal to 1 divided by s plus 1, s plus 2 and s plus 3. So we can write this equation as y of s divided by u of s is equal to b naught by s plus 1 plus b2 by s plus 2 plus this should be b1, okay, b2 by s plus 3. Now we need to find the value of b0, b1 and b2. Okay, so we know how to find this. I'll take the direct value. b0 is 1 by 2, b1 is minus 1 and b2 is 1 by 2. Okay, you can solve this equation. Now y of s is equal to 1 by 2 u of s divided by s plus 1 plus, right, u of minus u of s divided by s plus 2 plus 1 by 2 u of s divided by s plus 3. Now we will take this as x1 of s, I will take this as x2 of s, and this one is x3 of s. So we can write y of s is equal to x1 of s plus x2 of s plus x3 of s. Now what is x1 of s? x1 of s is equal to 1 by 2 u of s divided by s plus 1. This is x1 of s. So can we write this as s into x1 of s plus x of s is equal to 1 by 2 u of s, right? Now what is s x1 of s? Inverse Laplace transformation of s x1 of s, that is d by dt of x1 plus this should be x1 of t is equal to 1 by 2 u of t. Okay, now I'll take this as x1 differentiation of x1 is equal to minus x1 plus 1 by 2 u. Okay, now similarly we will find for x2. Okay, so x2 is minus u of s by s plus 2, right? So x2 of s is minus u of s by s plus 2. Now we can write this equation as s into x2 of s. So I will write directly. Okay, so it will be inverse Laplace transformation of this. So this will be d by dt of x2 of t plus 2 x2 of t is equal to minus u of t. So I can write this equation as x2 dash is equal to minus 2 x2 minus u. Okay, and what is x3 of s? x3 of s is 1 by 2 u of s divided by s plus 3. So we can write this equation as inverse Laplace transformation of this one is d x3 of t by dt plus 3 x3 of t is equal to 1 by 2 u of t. Now x3 dash of t, or I will write x3 dash is equal to minus 3 x3 plus 1 by 2 u. Now we have three equation. This is our equation 1, this is our equation 2, and this is our equation 3. Okay, now I'm going to use all these three equation and write state space model. So this will be x1 dash, x2 dash or x3 dash is equal to minus 1. See, x1 dash is minus x1 plus 1 by 2 u, right? So minus x1 okay, minus x1, and x2 x3 will be 0, so I'll put here 0, plus 1 by 2 u, okay, plus 1 by 2 u. So we'll write 1 by 2 u. Now x2 dash is minus 2 x2 minus u, so minus 2 x2, so this will be minus 2, and remaining x1 and x3 will be 0, minus 2 x2 minus u, so this will be minus 1. Okay, now third will be x3 dash. X3 dash is minus 3 x3, so this will be minus 3 x3. What about x1 and x2? That will be 0. Okay, plus 1 by 2 u, so this will be 1 by 2. Okay, and how we are going to write y? See, y is simply x1 plus x2 plus x3. Okay, right, y is x1 plus x2 plus x3, so I'll put here, okay, I will write it here, matrix y will be equal to 1 1 1, this will be x1 x2 and x3. Okay, so this is called diagonal canonical form. This is called, you can see the coefficient we have got in the diagonal term, so this is called diagonal canonical form. Okay, now next is direct decomposition method. Okay, so let's take y of s by u of s as a3 s cube plus a2 s square plus a1 s plus a0 divided by s cube plus b2 s square plus b1 s plus b naught. Okay, now in numerator and denominator I will take s cube as a common. In numerator I will take s cube as a common. Okay, so this will be a3 plus a2 by s plus a1 by s square plus a naught by s cube divided by 1 minus b2 by s minus b1 by s square minus b naught by s cube. Okay, so this look like Manson gain formula. How to do graphical representation of this one? So this is the forward path, right? This will be forward path, and this will be feedback. Okay, so there are 4 forward path. Okay, now let's draw this one. This is u of s, Okay, and from here this will be a naught so this is a naught into 1 by s cube, right? A naught by s cube, or we can tell a naught into 1 by s cube. So obviously we need to multiply 1 by s 3 times, right? So this will be 1 by s, this will be 1 by s, and this will be 1 by s. Okay, so a naught into s cube, and then we will get y of s. Okay, now what about a3? There is no s term, right? So we can directly put it here. This is our path a3. So this is a3. What about a2 or a1? A1 is what about a2? A2 is a2 into 1 by s. Okay, what about the second term? A2 into 1 by s. So we can put it here, a2 into 1 by s. Okay, now let's draw graph. So this is u of s, this is 1, and this is a naught. So this is a naught into 1 by s3, right? So this is a naught into 1 by s3. So we need to multiply 1 by s3 times, right? So 1, 2, and 3. So this is 1 by s, 1 by s, 1 by s. So we have completed first forward path. Okay, this is y of s. Now what is the second forward path? That is a1 into 1 by s square. So this will be a1 into 1 by s square, right? See this forward path like this. Okay, so a1 into 1 by s square. What about the third forward path? That is a2 into 1 by s. So this will be a2 into 1 by s. Okay, so this is the third forward path. Now the fourth forward path is a3. There is no 1 by s, right? So this will be a3. So we have successfully drawn all the 4 forward path, right? Now what about the feedback path? Minus b2 by s, minus b1 by s square, minus b0 by s cube. So this will be minus b2 by s minus b1 by s square. So minus b1 by s square minus b0 by s cube minus b0 by s cube. Okay, so this is the 3 feedback path. Okay, or we can tell loop. This is first loop b2 by s, this is second loop b1 by s square, and this is third loop b0 by s cube. Now take this point as x1, this will be x1 dash, and this point will be, because this is 1 by s. Okay, so s of or we can tell 1 by s of x1 is nothing but integration of x1, right? So this will give you x1. So we can take this as x1 dash, or this will be differentiation of x1 dash, that will be x2, and this will be x3. Okay, so I will take x1 dash as x2. Okay, so this will be x2 dash, and this I will take x3, so I will take this as x3. Now let's write equation for this one. So what is y of s? Y of s is u into a3 plus x1. Okay, so y of s is equal to u into a3 plus x1. Okay, so this is equation 1. Similarly, what is x1? So x1 is, sorry, x1 dash. So x1 dash is x1 dash is equal to, see यहाँ पे कौन कौन सा सिग्नल आ रहा है, दैट इज u इंटू ए टू प्लस x2 dash into 1 by s. So what is x2 dash into 1 by s? That is x2 plus x2, and from here y of s into minus b2 minus y of s into b2. Okay, so put y at this point, substitute the value of y at this point, we will get x1 dash is equal to ua2 plus x2 minus b2 into ua3 plus x1, or we can write we can take u as a common, okay, and write all the equation from x1 to x3. So minus b2 into x1 plus x2 plus a2 into minus b2 into a3 into u. Okay, so let's take this equation as equation 2. Similarly, we will write equation for x2 dash. Okay, so at x2 dash, this is the signal, which and all signal is coming at this point. See, first one is this, second one is this, and third one is this, right? So u into a1 at x2 dash, we are getting u into a1 plus x3 dash into 1 by s, that means integration of x3, that is x3 dash, so we will get x3, right? So plus x3 minus b1 into y, minus b1 into y, substitute the value of y, so u into a1 plus x3 minus b1 into y. So what is y? U into a3 plus x1. Now write equation from x1 to x3. So this will be minus b1 into x1 minus b1 into x1. There is no x2, so this will be plus x3 plus u into minus b1 into a3 plus u, sorry, plus a1 into u. So this is the third equation. Now third point is x3. So what are the incoming signal here? U into a naught and y into minus b naught. So x3 dash is equal to u into a1 minus y into b naught. Okay, so this will be u into a1 minus b naught. What is the value of y? Y is u into a3 plus x1, u into a3 plus x1. Now this will be u into a1 minus b naught u into a3 minus b naught x1. Okay, or we can write this equation as minus b naught x1 then plus a1 minus b naught a3 u. Okay, so let's take this equation as equation 4. So I guess I made a mistake here. This is a naught, right? So this should be a naught. Let me correct this one. This should be a naught. I made a mistake here. Please correct this one. This should be a naught. Okay, let's write this equation in matrix form. So I will copy first. This is x1 dash. So I mentioned here all the equation. Now I will write this equation in matrix form. So first I will write differentiation of the state vectors, that is x1, x2 and x3 is equal to, this will be minus b2 minus b1 minus b0. This should be x1, x2, x3 plus u. Okay, so first one is minus b2 x1 plus x2 plus a2 minus b2 a3 into u. Okay, so there is no x3 in this term, right? There is no x3 in this term, so we will write here 1 x2 and 0 x3. Similarly, and we have u term, right? a2 minus b2 a3 u, so this will be a2 minus b2 a3 into u. Okay, now x2 dash is minus b1, there is no x2 term, plus x3, so minus b1, there is no x2 term, plus x3. Okay, plus minus b1, or we can tell, okay, I have written here 2 times, right? So let me correct this one. This is x2, right? So okay, now so this will be a1 minus b1 into a3, so this will be a1 minus b1 into a3. Now b0, x3 dash is equal to minus b0 into x1, there is no x2, there is no x3, and here it will be a0 minus b0 into a3, right? And what is y? That is, y is, there is only x1 term, right? There is no x2 and x3 term, so this will be 1 0 0, x1 x2 x1 x2 x3 plus u into a3, this is a3 into u. Okay, so this is how we can write this equation in this matrix form. So this is called direct decomposition method. In this direct decomposition method, the matrix A comes out to be a phase variable. Okay, and I mention here, in direct decomposition method, the matrix A comes out to be a phase variable form. Okay, so in phase variable form, all the elements of either first row, either this row or last row, okay, should be negative, should be in negative form, and element just above the diagonal will be 1. That is, you can see this is the diagonal element, so the element just above to the diagonal element should be 1 and rest will be 0. Okay, so this is direct decomposition method, will get in this form.